by nature of having sensors on board, it can digitize how much movement you have, and it can play that back to you in a virtual environment. And that virtual environment is effectively a computer screen that presents you with information that your body and your brain can learn off of. This is called
Okay.
biofeedback. This biofeedback is absolutely essential for us learning how to move. For instance, let me just say my classic example here is picking up a cup of coffee. If there's no actual coffee in this yet, but later there will be. Now, if I'm
Yeah.
trying to learn how to pick up this cup of coffee, and I generate, and I've never done this before, let's just make a
Hmm.
hypothetical here. If I'm
Yeah.
trying to learn how to pick up this cup of coffee and I just generate some neurons to fire and I reach over here, I miss the cup, right? Completely miss the cup. But if I don't know that I missed the cup, right, and I don't know how much error there is, the distance between the cup and where my hand ended up, if I
Yeah.
don't know anything about the error, I have no information about how to refine that network of neurons that I recruited. And so
Okay.
what I have to have is I have to have an objective reality of, oh, I missed it by this much. Oh, I need to try to go here. Oh, I overshot it. Let's try to go in the middle. And now I've hit the cup. So it's that process of learning from error and learning where the objective reality is. And that's the learning
Hmm.
process that we have to basically do. The Motus hand can help us do that because it can sense those movements that someone is actually inducing. And we can tell people what are good movements and what are not so good movements. But what's really cool is it's not just, this is especially relevant for you, Chuck, because you're telling me that you have on the lower side of movement capabilities. What's really cool is that this shroud right here actually has the capacity to flex and contract. There's an actuator in here that can help you initiate your movements. So
Okay.
for someone who has a tough time or a very, very challenging time trying to initiate or amplify movements or try to have access to the full range of motion, this actuator, this muscle, can take over and provide some assistance. So we call this a dynamic assistance capabilities. And so it can
Okay.
sense and help you move. And these things work together in addition to the biofeedback, help provide a context of this neuro-rehabilitation sort of paradigm. And then we
Hmm.
wrap this all together into a with some artificial intelligent algorithms to learn how best you are performing. And we have a rehab program that you can do in your home that can complement your rehab at your clinic. So that's really
Yeah.
kind of that's kind of the fundamentals of this. And it took us the better part of, I don't know, let's say 7 years of clinical validation, and then we did another 5 or 7 years of home validation in the VA. So before that, we did a big randomized multi-site control trial with Emory University here in Atlanta, Georgia, where I am, in the Cleveland Clinic. That was one of the big studies. And then there was a large, what we call an implementation study, which is randomized control trials are good, but they're kind of sterile. And we need to see how this works in the real world. And those implementation studies we ran with the VA helped us figure out how these devices can be used in the home. And we tested again its safety and its efficacy, so how safe it was and how effective it was in the
Hmm.
context of a home when there isn't necessarily a clinician there the whole time.
Right.
So we've gone through a long process of learning about how to best develop an intervention, make it safe and effective, and then also how to make it accessible to individuals. And that's kind of where we are now. And so we've been doing this for quite a while, I'll say.
Yeah.